dear students, welcome to the lecture series on the topic Engineering Graphics. Today we are going to discuss about isometric projections. I am Dr. IPS Ahuja, Professor, Department of Mechanical Engineering, Punjabi University, Patiala. Now today we are going to discuss about the isometric projections of a V block. So here we have got the construction of the V block. So this is the front view orthographic projections of the V block, and this is the top view projections of the V block. So we have been provided with the front view and the top view orthographic projections of the V block. So using the information available to us through the orthographic projections in the front and the top view, we are required to draw the isometric projection. Now you see, in this particular case, once the orthographic projections are given, we need to work out the sizes of the front face, the top face and the side face of the isometric projection. Why? Because in the isometric projection we have to draw a 3D projection in which the front face of the solid, the top face of the solid and the side face of the solid, that is all the three faces of the solids, will be represented in a single plane over there. So before we start constructing the isometric projections, we need to evaluate from the information which is available to us through the orthographic views. We need to evaluate the sizes of the three faces. So let us work that out. So in the front view, we can check that the length of this object happens to be 80 millimeter. So the front face of the solid will be having one dimension as 80 millimeter, and the height of the object is also available to us in the front view, which is equal to 40 millimeter. So the front face of the solid will be represented by a rectangular face which will be having the size 80 millimeter by 40 millimeter. Similarly, the top face. Now the top face, once again, the length of the top face will be equal to 80 millimeter, which will be same as the length in the front view. Now over here, the width of the solid is given to us as 30 millimeter. So the top view dimensions will be 80 millimeter by 30 millimeter. So this rectangular surface which will be drawn onto the isometric projection should have the dimensions equal to 80 millimeter by 30 millimeter corresponding to the top view. Now regarding the side view, in the side view we are going to represent, please check, this is the width of the solid. So width will be 30 millimeter, and the side view will also be showing, besides this width, the height of the solid. So the height of the solid happens to be 40 millimeter. So the side view face, the size of the rectangle which is going to show the side view, it should be 30 millimeter by 40 millimeter. So this is how you see we have planned that we are going to show all these rectangular faces onto the isometric projection. That is, along the x-axis the side view will be shown, and side view we have already discussed, this is 30 millimeter by 40 millimeter. So the width of the side view should be 30 millimeter, the height of the side view should be 40 millimeter. Similarly, the front view length of the solid should be 80 millimeter, height of the solid should be 40 millimeter. So this is 80 by 40. Similarly, the top face. So in the top face you can check, this is the length of the solid which is equal to 80 millimeter, and this is going to be the width of the solid, so which will be 30 millimeter, right? So this way the top face of this rectangle which will be shown onto this isometric projection should be 80 millimeter by 30 millimeter. So in order to start the construction of the isometric projections, first of all we need to complete this rectangular prism or a cuboid onto the isometric projection, so that we are able to identify front face, top face and the side face of the solid, and then depending upon the orientations and the cutting of the different edges of the surfaces over there, depending upon the changes in the cross sections of the different elements of the solid, then we are going to plot all these variations in the cross sections of the solids. They will be plotted into the isometric projection. So let us start with construction of these three rectangular faces onto the isometric projection. Now, in order to complete the construction of isometric projections, the first thing is that whatever distances are available over here corresponding different components of the solids or the different elements of the solid. So all these dimensions we have to first of all draw it onto the true scale, and then all these true dimensions will be converted into the isometric length dimensions, and once these dimensions they have been converted into the isometric lengths, only then we can start with the construction of isometric projections of this V block onto the isometric plane. So let us start with the construction. So step 1, we have the isometric length scale drawn, and then conversion of all the dimensions into the isometric lengths. Then we have the ground line. So please check, this is our horizontal ground line or the datum line. Now on this line, the x-axis will be drawn along the left side. So please check, we have drawn the side view towards the x-axis side. Okay, so this is the x-axis side, and in the side view there are two things which will be available. Number one, width of this particular solid and the height of this solid. Width of the solid is equal to 30 millimeter. So we have marked this width of the solid along the x-axis. So this is our x-axis. So along the x-axis we have marked this distance is equal to, please check, this distance happens to be 30 millimeter. So in the side view, this distance will be shown as 30 millimeter isometric, right? So this x-axis has been drawn at an angle of 30 degree. And the second dimension which is going to complete the side view, this is the height of the solid. So this is the height of the solid. So how much is the height of the solid? It is equal to 40 millimeter. The height of the solid will be equal to 40 millimeter. So we have drawn this rectangular face towards the side, that is on the left hand side. So this we call as left side view. Why? Because we are looking from the left hand side over there onto this particular face which is going to represent the side view of this V block. Now please check, this is the height which is equal to 40 millimeter. So the one face of the 3D object, that is the V block, we have drawn onto the isometric scale. Now let us complete the front face. Now in order to draw the front face, you see, I have to move along the z-axis. So the z-axis will be showing me this length which is equal to 80 millimeter. So once again, the isometric length of 80 millimeter we are going to obtain from the isometric scale, and then this length we are going to plot along the z-axis. Now this is the front face, you can check, which is having the dimensions 40 millimeter. So 40 millimeter we had already marked while we were drawing the side view over here. So while we were drawing the cross section corresponding to the side view, so this 40 millimeter edge we had already drawn. So what we need to complete this front face, so we have to mark 80 millimeter length along this z-axis, then two isometric lines. This is one isometric line, this is second isometric line. So this isometric line we have drawn parallel to this edge, that is the base which is equal to 80 millimeter. So the length of this edge will be equal to 80 millimeter. Similarly, from this corner I have to draw another vertical isometric line which will be parallel to the y-axis. So the height of this particular edge will be 40 millimeter. So this is also 40 millimeter, this is also 40 millimeter. So this vertical edge, it is an isometric line which is drawn parallel to the y-axis over here. So this is 80 millimeter, and this is the front face that we have completed. Now we need to complete the top face over there, and top face we know the dimensions of the top face will be 80 millimeter by 30 millimeter. So in the top face, once again you can check, this is my 80 millimeter, right? So this is the 80 millimeter length corresponding to the top face, and this is my top face over there. So through the top view the dimension of the top view will be 80 millimeter, which I have already marked, 30 millimeter, which I had marked initially when I was drawing the side view over there. So if I draw an isometric line which will be parallel to the z-axis having length equal to 80 millimeter, similarly another isometric line I have drawn in order to complete the base of the solid, which is isometric line or the edge which is parallel to the x-axis, and this dimension will also be equal to 30 millimeter. Now we have to complete the top face. So in order to complete the top face, you see I have drawn another isometric line which is parallel to the z-axis and one more isometric line which will be parallel to this x-axis. Now you see this is nothing but it is a rectangular prism. So this is a rectangular prism in which the dimension of the rectangle is 40 millimeter by 30 millimeter and the base dimension is 80 millimeter, right? So it is resting on its base which is having the side 80 by 30 over here. So through this construction of the rectangular prism, we have been able to develop three things. That is, I have been able to develop this left side view face over here. This is the face through which I will be developing my left side view of the isometric projection. This is the face of this particular prism which is going to show me the front face of this V block, and this is the top face of the rectangular prism over there. Now all the three faces we have been able to locate. Now we have to see the changes, we have to evaluate the changes in the cross section of the component over there, and by integrating the front view and the top view information, now we are going to start with locating this exact V block into this cuboid or into this rectangular prism that we have drawn, right? So we know that this is going to be our front face. So if you evaluate the front face, one thing we are able to understand, that is there is the lower segment. You see there is the lower segment of this particular V block which is measuring the height equal to or thickness is equal to 15 millimeter. So if I divide this solid into number of parts or the elements, so this is the first element which I am going to start with. You see this is the lower portion of the block which is a solid block, and this portion is measuring 80 millimeter by 15 millimeter. So this is going to be a web which is having this thickness over there, right? So this is the lower portion of the V block. So now I am going to draw, you see, a web over here. Just check, I have drawn a web over here which is at a distance of 15 millimeter from the bottom. So this is the web or the lower thickness of this particular element of the V block. Okay, so a construction line has been drawn so that we can have this web, it is going to run across the entire length of the object. So through this we are able to identify this portion of the component over there. So even though this is not continuous, we will find out where this cross section will be located. But to begin with, this is going to be my starting point. So my starting point is a lower portion of this V block which is having the height or the thickness is equal to 15 millimeter, that we have been able to plot. Now there are two more things to it. That is, this is the upper portion of the shorter web which is vertical, this was horizontal, this is the vertical web over here which is having, now I have to integrate information of the front view with the top view. In the top view I get the measure of this thickness. So at what distance this web is starting, so this portion of the lower part of this component will be straight one, and up to which you see length this will be straight 20 millimeter. The length of this segment is 20. Similarly, the length of this segment is also 20, and after you move 20 millimeter along this 15 millimeter thickness of this block, lower end of the block, then there will be a vertical wedge. So this is a vertical wedge or a vertical wall or a vertical face of this V block. Similarly, on this side, after you move around 20 millimeter, this is the vertical face of this V block wedge over here. And then what is the thickness of this web at the top? 5 millimeter. So this is also 5. So I have broken this total information of 80 millimeter, 20 millimeter, it will be straight through a thickness of 15 millimeter. Similarly over here, up to a distance of 20 millimeter towards right, and the thickness of this block will be 15 millimeter. Then I have to move up how much? 25 millimeter. Now the vertical distance will be how much? 25. Then there will be a web of 5 millimeter and 5. So how much distance we have used? 20 plus 5, 25. How much distance we have moved? 20 plus 5 equal to 25. So total 50 millimeter. And in between how much distance is there? 30 millimeter. So this distance happens to be 30. And if you look at it from the top view, this is the change of cross section. So this, you see, this solid line is going to represent the change in orientation of this slant edge over here. So this slant edge, it is moving from top to bottom, and then from this point it is moving from bottom to the top, so that you get the formation of a V over here. So this distance is equal to 15 millimeter. So the total distance is 30 millimeter. So this distance is 15, this is also 15. Now we have broken down this total information of the component into small element. Now let us plot all of these things over here. Now step number 1, I know that the distance between this corner and the vertical face of this web, this is equal to how much? This is equal to 20 millimeter. Please check. This has been provided to me through the top view over here. Similarly on this side, 20 millimeter, you move from the right corner and you are going to get the location of the vertical web over here and vertical web over here. Now I have left 20 millimeter from the left corner, and from here, please check, I have drawn a vertical web. Please check. How did I draw this vertical web? Please check. This is my 20 millimeter distance, which is corresponding to this portion. So I am moving from here. As I move along up to this point, from left to right, now I have to move vertically downwards. How much? 25 millimeter. That is up to this ring over here. This ring is having the thickness 15 millimeter. So from the top, what I have done, once again, I have drawn an isometric line which is representing the height of this web. Please see, this is the height of this web, and this is equal to 25 millimeter. Okay, so I need not mention this 25 because I have already mentioned 40 millimeter is the total length, 15 millimeter is the length of the lower block over there. So once I move 25 millimeter down the line, so this is the isometric line which is parallel to the y-axis. Why? Because it is a vertical dimension. This is also a vertical dimension. So I have moved vertically downwards, and then this web from the top view I can see it starts from this point and it goes parallel to this edge. Please check. This edge is parallel to one of the elements of this web, and this is also parallel. Similarly, this is also parallel to the side view edge over here. Similarly, this is also parallel to the side view edge. Similarly, these two edges of the second web, they are also parallel to the side view elements over there. So with respect to this x-axis, that is where we had mentioned this 30 millimeter over there. Okay, so corresponding to this edge, now I have to draw another isometric line which will be parallel to the x-axis, and then because it is running end to end, so I have to draw once again a perpendicular of 25 millimeter length. That is, it should be ending up at the ring that we have created, which is at a distance of 15 millimeter from the bottom. And since it is going to end up over here, and this distance will also be running through the entire length, so I am going to join this point with this point. So this gives me the complete vertical face representation. Please check. This gives me the representation of the vertical face, and please check, this is at a distance of 20 millimeter from the side over here, from the leftmost edge of this particular V block. So I have been able to draw the wall which is having the dimension 25 millimeter is the height, and 30 millimeter is the width of this particular wall. Okay, so this is a vertical wall having a thickness of 30 millimeter and a height of 25. So we can check. This is the height of 25 millimeter. This is the width of 30 millimeter. So this wall of the first web has been drawn. Now I know the thickness of this web. How much is the thickness of this web? 5 millimeter. So I can mark another 5 millimeter over here, and the second internal edge of this top web has been located. So internal wedge of this top web. Okay, so this is my internal edge of the top web. So please see, this is my first web, this one. So the second line, for which is again running through the entire length of this particular solid, that is, which is going to run through the entire width of this particular solid. So this has been drawn. So first web has been drawn over here. Similarly, I'll start from the other side. If I have to start from the other side, please check what are the dimensions which I will be requiring. Same dimension, that is, this distance from the rightmost corner, this happens to be how much? 20 millimeter. And then the thickness of the web, it is equal to 5 millimeter. So please check, I have drawn 20 millimeter from the rightmost corner, drawn the first edge, that is this edge, outermost edge of the second web. So the outermost edge of the second web has been drawn. So the width of this web is equal to 30 millimeter. Please check. And the depth, this is the depth of the vertical wall. So the depth of the vertical wall will be 25 millimeter. So total is 40. 15 is the thickness of the lower block, and remainder 25 millimeter is the depth of or the height of this vertical wall. So this is equal to, once again, how much? 25 millimeter. So we start from here, we end up at this ring. So this ring locus line we had drawn so that we can easily measure all the other distances over there. Now this vertical horizontal edge, that is this one, and the vertical edge, that is this one, has also been drawn. Now the thickness of this web we have drawn. How much is that? 5 millimeter. Now we are left with, please check, we are left with 30 millimeter distance in between, or if we include the web, all these, you see webs over there, this web is having 5 millimeter thickness, this web is having 5 millimeter thickness. So the total distance between the outermost portions of these vertical walls, this happens to be 40 millimeter. Please check, 5 plus 15 plus 15 plus 5. So from this end to this end, the total distance is it is equal to 40 millimeter. Now we know the distance between these two vertical walls. How much is this? 40 millimeter. Why I am now talking about this 40, whereas this is equal to 30 and this distance is equal to 15 over there? Because I have not marked these distances on the lower wedge over there. So that is why I am bothered about distance between external vertical walls over there. This is first vertical wall, this is second vertical wall. So distances between this vertical section and this vertical section happens to be 40 millimeter. And how much is the distance of the center? The distance of the center, this one, this happens to be 20 millimeter. So from this point it is 20, from this point it is again 20. Now what I am going to do, I am having total length is equal to 40 millimeter. So I will be measuring the distance of midpoint. Midpoint of this 40 will be 20. The moment I measure this length of 20 millimeter from either this vertical wall or from this vertical wall, I will be getting the location of this V point. That is the lower point where this V will be formed, where this cross section and this cross section, that is having the opposite slopes, they are going to meet over there. So this is one cross section of the V, this is second cross section of the V. Now you see we have obtained the entire structure. So the structure has been created. Now all the elements of the V block have been identified and they have been located into this rectangular prism that we had developed using the information given in the front view and the top view. Now we will be starting with darkening of the elements of this particular V block onto the isometric projection. So let us start with that. So please check, this web is visible to the observer. This web, it is visible to the observer. So I have darkened this top portion of the web 5 millimeter by 30 millimeter. Please check, this is 5 millimeter by 30 millimeter. This is the top web. Then we had discussed that this is a vertical wall. So this vertical wall is having the dimension, how much? 25 millimeter is the height and 30 millimeter is the width over here. So please check, 30 millimeter is the width of this vertical wall and 25 millimeter is the height of this vertical wall. So all the four elements of this vertical wall, they have been identified. Then there is this surface, which is flat surface having the thickness of 15 millimeter, and this is the thickness of 15 millimeter and the width is equal to 20 millimeter. So this is the width of this segment of the V block. So please check, this is the 20 millimeter thickness over here, which we have mentioned 20 millimeter, and the thickness of this section, of which is lying on the left side, it is equal to 15 millimeter. So this portion also we have darkened. So this is a flat surface which has been obtained, and this is the side view of this segment. Please check, this is side view of this segment. So side view of this segment will be 15 millimeter is the height and 30 millimeter is the width. So it is this edge that we are talking about. Please check, only this edge. So this edge will be 15 millimeter high and 30 millimeter width. So this is 15 millimeter high and 30 millimeter width over there. And then in the front view, you see there is not, we haven't drawn a dark line over here. It means this is a integral portion over there. So I need not join this thing dark. So we have to draw this vertical wall, and then this particular dark line we need to develop over here. That is, this is one piece. So had we got one solid line over here, it means that there is some change in cross section over here. So since this is a single surface, so we have not drawn a solid line between these 2 points over here. Now having obtained the base, now this side, that is the right side of this block, will be developed. So regarding the right side, once again you can check, this is my second web which is having the thickness 5 millimeter by 30 millimeter. So this has been drawn. The vertical wall which is having the depth or the height is equal to 25 millimeter. This has been drawn. Now this is the right side of the shorter portion which is having the dimension 20 millimeter and the height is equal to 15 millimeter. So this is 20 millimeter and this height of this segment is 15 millimeter. And this portion we have to join, but this portion of this side, that is this portion, so part of this portion has been covered by the front portion of this V block over here. So that is why this portion we need not draw dark over here, right? So this portion of this flat surface has been covered by this V block. Okay, so now through this we have been able to draw the front portion, but one thing is remaining, that is, this is the surface. Please check, this is the surface which is having these two starting points. This is my starting point which is lying over here, which is at a thick height of 15 millimeter, and this is going to start 20 plus 5, 25 millimeter from this end. So this slant edge has been joined over here, but I have not joined the back side of this slant surface. So I need to join the back side of this total slant surface. So this slant surface will also be having the back end. Now I do not have any, you see, measurement for this. So how to draw this? So the slope, please, one thing I need to check, that the slope of this back surface will be same as the slope of this front surface over there. So I'll be measuring this slope, and by measuring this slope, now I can draw the back surface corresponding to this sloping edge of this particular V block. So this is an additional thing which we might need to do, which many of you might be forgetting, because we have drawn everything which is visible to us. but this surface is visible. And you will ask a question, what about the back side of this? The back side of this will be again having the same slope. And if you draw the same slope, you will find from the back, if I draw this line, I'll be finding that this is going to be covered by this front face. So that is why this back surface slope corresponding to this wall, that is this particular wall, has not been shown over here, right? So this is the complete construction of isometric projections of a V block, and this construction has been completed through the data which was available to us through the orthographic projection. So first thing we need to remember, first of all, you draw a cuboid or a rectangular prism which will be showing three faces of the solid, and then you work out the surface changes or surface discontinuities. You observe all those discontinuities or changes in the surfaces from the different views which are available, and then try to break this total information into elements and pick every element one at a time. So we have started with, this was our first element, which a block which was having a shorter thickness. Similarly, then we picked up this element, then we picked up this element, then we picked up these two elements. So this way you need to break up the information of the complete solid into the elements, and only then you will be able to complete the construction of the isometric projections from the information of the orthographic views which are available, right? So this is all for today. So I hope that through this discussion you would have understood about how to make the isometric projections based upon the information which is available to us through the orthographic projections. We will be continuing with discussion regarding few more cases of construction of isometric projections through the orthographic projections in the next classes. So thank you very much. Thanks a lot. Thank you.